Okay, so I wanted to go over the reflection that we had this week, and just go over A and B just to make sure that everyone is on the same page. All right, so I asked two statements, and I wanted you to just state whether you agree, disagree, or you were not sure. Now, the first one states that if the limit of a function at a point exists, then so does f of a. All right. Now, for this one, this is a disagree. Right. If we think of, well, an example of, and I believe one of you posted this example in the discussion. All right. If you look at this example here. Okay, now if we look here, if this is our function f of x, then clearly we could see that f of 1, right, is undefined. Right, we could just not plug in, we'll be dividing by 0, right? So that is not something that is defined, right? But for the limit, I can do this, right? And now we have a simplification that leads me to this quantity where I can simply plug in 1 and I get a value of 2, right? And the limit exists, right? It is one finite value, but the function value is undefined, right? So this is an example that contradicts it, right? And again, as long as there's one example, then we could say disagree, right? There's just, we have to take it on a case-by-case basis, right? So if we think of, well, what does the graph of something like this look like, right? This actually is a graph of x plus 1, right? This type of function has what's called a removable discontinuity. Right, where instead of, so here would be x plus 1, 1. Sorry, this should be an open circle here. Right. So the graph is defined near it, right? It's approaching this value here of 2, right? But at the actual value x is equal to 1, the function is undefined. Okay, so remember, one of the key kind of points in this chapter, which I think a few of us are still not clear on, is the limit doesn't tell me anything about the function value at that particular point, right? The limit is only telling me what is only information of what is happening around a certain value, right? Not at the value. That would require a little more investigation. So based off what we can deduce from the limit, that doesn't tell us of what is the function value. All right, so that was for part A. So for this one, this should be a disagree. Okay. Now for part B, we stated if a limit left, right, two-sided of a function is infinite at a point, then the graph of the function has a vertical asymptote at the point A. Now for this one, this is an agree for this statement here, right? So let's take a look at why that has to be the case, right? So let's just look at some graphs here. Let's say that we had, call this A. Okay, and let's say that we have the limit as x approached a from, let's say, the left side of f of x is equal to infinity. Right? So if I have that, right, it's infinite. So then that looks something like that. All right, and we see that it follows that asymptotic behavior where it kind of is approaching it, right? But it never quite achieves a value at A, right? It just, the closer I get to A, in this case, the larger in the positive direction that value becomes. Okay. Now, if it were on the other side, right, in this case, we think of, well, look, it has two separate limits, right, where one of them is positive infinity and negative infinity. Well, in this case, we still have the same asymptotic behavior, where the closer I get to A, the bigger that function value gets, but in this case, in the negative direction. Right. Now, if this were, let's say the limit was, let's say you got another point out here, we'll call it B, and let's say that the limit as x approached B of f of x was negative infinity. All right, so in this case, what would happen is, all right, on both sides of it, right? So that's a two-sided limit. So regardless of whether we are on the left or the right, the closer I approach B, the larger that value becomes, right? So it never achieves a finite value. It just keeps getting larger and larger and larger, right? So that we see here that in any case, if I know that the limit is equal to infinity, then right away what that is telling me about the graph is that there is a vertical asymptote there. Okay, thank you.